Good morning, everyone. So the purpose of this meeting is to discuss about the driver tax and schedule. So today you guys need to deliver the products to the following customer, and you also need to visit the suppliers as well. And here is the delivery schedule for today. I am really sorry, boss. I could not make it today because today is my daughter's birthday party. I need to be there on time. According to today's driver schedule that you gave me, I cannot be there on time for sure. I can't really manage the better time for you because it has been scheduled. Moreover, today customer and suppliers are important for us. I will give you an OT instead. Is it okay? I plan all of this schedule based on my experience. This is the best transportation schedule for all of you. I am really sad right now that I could not make it for my daughter. I will tell my wife and daughter that I could not make it today.
Hold on, I think the weaknesses from this transportation schedule for today. But don't worry, I think I can make it better and faster with the traveling salesman model from the management science technique. This way, driver 1 can go to his daughter's birthday party on time. Moreover, it will help us to reduce costs from transportation as well. Based on my experience as the network manager, I'm going to propose the traveling salesman framework to solve this network model issue. The problem that we're facing is that we only have 3 drivers, and they're all being assigned to one customer or one vendor at a time. What this means is that each driver is currently driving from the warehouses to the destination, then back to the warehouse, and they repeat this process for every single destination. So we can start seeing that some issues will arise based on the daily schedule sheet, with the urgent levels being divided from 1 all the way to 5 to indicate the urgency levels based on the time, with urgent level 1 being the most urgent. Since all the orders today are being placed at urgency level 1, it will make it almost impossible for all the drivers to deliver it within 10 a.m., given that they start working at 8 a.m. Therefore, it is time to make some changes to our current system. With our current approach, we're actually wasting 8.89 hours to deliver all the goods to the customers and vendors. We can actually save so much time since all the drivers are required to drive back and forth, and they're actually driving at a total distance of 338.2 kilometers. That is why I'm proposing the traveling salesman problem approach that will help us address the question of, given a set of destinations and the distances between each pair of destination, how can we find the shortest possible route that visits each destination exactly once and returns to the starting point? To start off, I'm recommending that we group all the customers and vendors into 3 clusters called Group 1, Group 2, and Group 3. The destinations are then grouped based on their proximity to each other. Therefore, as we have 3 drivers, each driver will be assigned to 1 cluster. However, as Lam Chabang Port is located the furthest away from all the destinations, I have decided that we should assign 1 driver for the journey to the port and back to the company. Therefore, if the driver is traveling to the port, they would not need to deliver any goods on the way. This will make it so much easier for the drivers as they can deliver all the goods in the given destinations in only 1 group, and this all requires 1 car journey. So this will allow us to save a total traveling distance of 131.94 kilometers and make our overall journey faster by 122.37 minutes. So we assigned a number to each destination and we let solver figure out the shortest route based on the destination provided in the graph. The graph includes the distance from all the distance traveled from the customers and vendors. Then solver then proposes the best order for the driver to deliver the goods to ensure that they arrive back to the warehouse in the shortest amount of time. Then I made a separate table and included a cluster with an additional destination that was not originally in the group to demonstrate that the distance will go from 30.93 to 72.12. This shows that clustering them into different groups will make it most efficient. From all the following management science techniques in the network model, we have a better route for the company and for the driver, and the driver will be able to go to the daughter's birthday party on time.
Thank you so much for your help. So I will leave the office now in order to go to the birthday party on time.
I think we are facing the problem with the high inventory cost. So proper inventory management is the key to reducing the cost and gaining more profit. Can you find a new solution to balance the product and the cost of inventory?
I'll try to apply the management science technique with the inventory management, but it will take a while because we have never applied the technology to categorize the products before. Also, the challenge is that we have multiple product types and not enough cash flow to stock the products unlike other big companies.
I totally understand. Please feel free to take your time and show me the method tomorrow.
Good morning, accounts manager. Today, I'm going to present a solution to the inventory management problem by using linear programming. So the problem that we're having right now is that the company has no order scheduling system. Therefore, the order scheduling is purely based on experience and led to the problem of being unable to fulfill around 70% of the customer demand. That's why we came up with the order scheduling model in order to identify the number of products that we have to order for each month. The model is based on the GIC system. The objective here is to minimize the total cost, and the decision variable is the number of products that we have to order each month for the top 3 products that have the highest demand. Based on the historical data of the previous year, we found out that the products that have the highest demand are plates, pipe, and bulbs and nuts, where we have given the code name of V1, V3, and V8. And we calculated the average cost of goods sold based on the historical data from the previous year. Then we have to identify the constraints. In this case, our budget amounts to 800,000 baht, and the maximum storage capacity is 2,600. Moreover, the demand of each month also needs to be met. We then set up these constraints in the solver parameter. Here, the total ordering unit has to be less than or equal to the ordered capacity, which is calculated by dividing the total budget by the average cost of goods sold of each month. Also, the on-hand after production for each product type should be more than or equal to the demand, which is based on the average demand of the previous year. Lastly, the total ending inventory should be less than or equal to the storage capacity. After using the solver function, the order scheduling is as follows, and the total cost is 1,601,059.42 baht.
Question: why don't we use the just-in-time system instead of the just-in-case system so that we don't have to pay for the holding costs?
Good question. Even though we do not have to pay for the holding cost, the total cost for the JIT system is higher than the JIC system due to the higher ordering cost. If we use the JIT system, the total cost will increase to 2,486,387.07 baht. Also, we can see that the JIT requires a higher budget for each month.
Oh, I see. Thank you. That looks good. I'm sure that your method will solve the problem that we are currently facing.